Dear students, if you have not written the solved examples 3.1, 3.2 and 3.3, please write it. They are very important, and now I hope you understand them very easily because we have solved many problems. Now we'll understand about the conductance of electrolytic solution. So now we want to understand about the conductance of the electrolytic solutions. For understanding the conductance, we need to revise few terms and we need to learn few more terms. First, we need to understand about the electrical resistance. So let us try to understand about the electrical resistance. Electrical resistance represented by R. It should be represented by R and is the characteristics of a substance that oppose the flow of current. R is measured in the unit ohm. The SI unit of O is kilogram meter square plus Siemens cube A square. The electrical resistance of any object is directly proportional to its length L, and it's inversely proportional to its area of cross section. So more is the length, more is the resistance, more is the cross section area, less is the resistance. So we can write R is equal to L proportional to L by A, or R proportional to L by A, or if we remove the proportional sign, we get a proportionality constant that R is equal to rho L by A. Removing the proportionality, we get rho as a constant. Rho in, like, we can read it as a rho, and the constant of proportionality here, rho, is called the resistivity or specific resistance. So my dear students, your rho is resistivity or specific resistance. This resistivity or specific resistance has got a unit. The SI unit of resistivity is ohm into meter and or ohm into centimeter. IUPAC specially recommend that we should call it resistivity rather than the specific resistance. So now onwards we will mostly use the word resistivity. Definition of resistivity: the resistivity for a substance is its resistance when it is on one resistance when its length is 1 meter or it's 1 meter long and its area of cross section is 1 meter square. It can be seen that 1 ohm into meter is equal to 100 ohm into centimeter, or 1 ohm centimeter is equal to 0.01 or 1 by 100 ohm into meter. Now we want to understand the conductance. The inverse of resistance R is called conductance, represented by G. So G is equal to 1 upon R is equal to A upon rho L is equal to kappa. This kappa is known as the conductivity, where kappa is equal to 1 upon rho. So this is how we understand the conductance. Now we'll understand the units. The SI unit of conductance is Siemens, represented by the symbol as. Siemens is nothing but your ohm inverse, or we can represent it with this symbol. Ohm inverse is even called as mho. OHM is simply returned as MHO. So ohm inverse or mho or Siemens, all three are same. Conductivity or specific conductance, kappa. The inverse of resistivity is called conductivity, specific conductance. Symbol of conductivity or specific conductance is kappa, which is a Greek letter. Again, IUPAC represents that instead of calling specific resistance, we should call it as a conductivity. So we will use the word conductivity most of the time. The SI unit of conductivity are Siemens per meter or Siemens per centimeter. Siemens per meter definition. Conductivity of a material in Siemens per meter is the conductance when its means materials is 1 meter long and its area of cross section is 1 meter square. Please note that 1 Siemens per centimeter is equal to 100 Siemens per meter. Let us prove it. 1 Siemens per centimeter, that is 1 Siemens divided by centimeter. 1 centimeter is equal to 1 by 100 meter. Therefore, we put 1 centimeter like 1 by 100. Denominator of denominator will be numerator. It is 100 into Siemens divided by 1 meter, which is 100 Siemens per meter. So this is how we understand the various terms and their units, my dear students. Conductivity kappa varies or it depends upon the nature of material. Kappa depends upon temperature. Kappa depends upon pressure. Materials are classified in the various categories depending upon their magnitude or conductivity. So according to their conductivity, we divide materials in various classes. The first class that we understand is known as conductors. Conductors have very large conductivity. The examples of conductors are metals, alloys, carbon black, graphite, some organic polymers. We will study in detail about some organic polymers. Semiconductors. Now this is the second class of material. Semiconductors have very conductivity less than conductors but more than the insulators. Silicon, doped silicon, gallium arsenide are the examples of semiconductors. Then we have the semiconductors are the important electronic material. My dear students, you are well aware that the computer chips, or you can say transistors, PNPN, NPN junction transistors and oscillators and all this diode, triode, tetrode, these all things are made up of semiconductors. Then we have the another class of material which are known as insulators. These insulators have very low conductivity. The examples of insulator are glass and ceramics. A very important and a different class of material which is known as the superconductors. So some materials like metals and their alloys which are having the temperature around 0 to 15K, or some ceramic materials which are having the temperature around 150K up to 150K, they show zero resistivity. The resistivity is zero. That means whatever the amount of electricity we pass, all the electricity will be passed without any kind of resistance. That means they have infinite conductivity, and these substances are known as the superconductors. Note that superconductors work in between some temperature range. That is what I have already discussed, that some alloys and metals, they behave like superconductors between 0 to 15K, and the ceramic materials behaves like superconductor at around 150 Kelvin temperature, which are generally the low temperatures. Now we want to understand the metallic conductance. So electrical conductance through metal is called the metallic conductance or electronic conductance. We know, my dear students, that when the electricity is passed to the metals, electricity can easily pass, and metals are good conductor of heat and electricity. So the conductance which is done by metals is known as the electronic conductance or metallic conductance. Thank you, my dear students. Hope you learn well. Namaskar.